Alright, so we're still looking at real numbers, classifying real numbers, properties of real numbers to evaluate expressions. And I think we talked about these already a little bit before, so this should be pretty easy. So let's work backwards. Okay, my natural numbers is what? What are my numbers for natural numbers? Did we talk about this earlier?
Number 1.
Yeah, you're counting numbers. 1, 2, 3, right? And so on. Okay, so this would be, if you're looking at these letters, it's the letter N, the smallest group, your natural numbers, okay? Whole numbers then is what?
0.
Yeah, 0, and then all the natural numbers. So 0, 1, 2, and so on. And that would be W. We're looking at that little chart. Integers includes what? It includes both of these sets. So I have 0, 1, 2, 3. What comes before that? All the negatives. So negative whole numbers. So -1, -2, and so on. And that is your Z. Irrational numbers. Kind of go out of order here. Irrational numbers are going to be what? I'll give you a hint. It's the I part. What were you going to say over here? Okay. Well, can. Some of them are valuable.
I have no clue.
No clue. Pi is an example of irrational numbers. Okay.
Infinite numbers.
Yeah, numbers that just keep on going. Okay. Another example would be like square root of 2. Okay. Decimal point just keeps on going. Doesn't stop. Rational numbers then. This would be letter Q on our chart. Now, if irrational decimals that don't stop, what would rational be then? Decimals that do stop. So, and it could be positive or negative. So we could have -2.25. Okay. Decimals that terminate. There's also another special type of decimals that do what? That repeats. Okay. So maybe I have 0.666 repeating, right? 2/3. And all of these numbers here that repeat and that stop can be written as a fraction. Okay. So 1/7 would be an example of that as well. Okay. Those are all real numbers. So if we're looking at these values and we want to identify where they belong, -185, what kind of number is that? So is it natural? No. Is it a whole number? No. Is it integer? Yes. If it's an integer, then it's also going to be what? It's also rational and real. Okay? So when you're doing something like, it's best to start with the smallest and work your way up. Okay? Square root of 95. And then don't say this. So how do I know what square root of 95 is? Calculator. So if I plug it in, what do we get? Does the decimal stop or repeat? It doesn't. 9.746794345. So if it doesn't repeat or doesn't stop, it's what? Irrational and real. -7/8. Okay. It's rational, fraction, and it's real. So these are different properties we can use, okay? Commutative property, again, that's just changing the order. I'm still adding the same things or multiplying the same things. Order is changing, okay? Associative property is what's being grouped together, okay? How they're associating with. Identity. Identity is adding or multiplying by something to get the same answer, okay? So identity is always adding 0 or multiplying by 1. The inverse, you guys use that when we're solving for equations, okay? Adding or subtracting the opposite value, okay? If it's multiplication, we're multiplying by that fraction flipped, okay? Or we kind of, sometimes we say dividing, okay? Closure, if AB is a real number, or if A times B is also a real number, okay? And then distributive property is when A gets multiplied into the parentheses. So I have A times B plus A times C if we have coefficients, okay? So why is there no commutative property for subtraction? Why is there commutative property for addition and multiplication? Why not subtraction? Well, what's commutative property?
If you change the order of subtraction, it'll change your answer.
It'll change my answer. So if I have 5 minus 3, I get 2, right? Well, if I change the order, 3 minus 5, I get negative 2. Those are not equal, so that's all you're doing. So order matters with order matters with subtraction, okay? And division. Example 3, Audrey went to a post office, bought 8 45-cent stamps and 8 32-cent postcard stamps. What's the total amount of money Audrey spent on stamps? Okay, so what equation can we set up? Was it 8 times 0.45 and 1? So we're taking the number of stamps bought times the price, we're adding it to what? The other part, right? 8 more stamps. 32 cents. And they want to know what the total amount of money Audrey spent on stamps was. Okay? So what's 8 times 0.45? 3.6? So 3.6, we're doing money, so I'll put a 0 in there. What about 8 times 0.32? 2.56. 2.56. And if I add those two together, $3.60 plus 256, $6.16. $6.16 on stamps. Okay. Does anyone know another way you could have done this? Again, this is like that distributive property, right? So I could have said, since I bought 8 of both, total cost per stamp for both, one of each, and I got 8 of them. Okay, so either way, it'll work out. Last example 4 here. So simplify the expression. Okay, so we're going to use those properties to help simplify, get rid of multiple variables and get rid of parentheses. Okay, so here, like to get rid of parentheses, we're going to distribute. So I'm going to take this 4 and distribute in. So 4 times 3a is 12a. 4 times negative b minus 4. Distribute in to 2. So 2 times b, 2b, 2 times 2a, 4a. Combine like terms. What are my like terms? 12a and 4a. So 12a plus 4a? 16a. Nothing else combines, so just bring them down. And minus 4.
Shouldn't that be a negative 4b?
Oh yeah. Yep. Sorry. This should be a b. Now we can combine what? Now we can combine our b's, right?
Minus 2b.
So now I have negative 4 and a plus 2, so I have a minus 4, or minus 2b. Sorry, my fault. Yeah, if I make a mistake, just let me know. And the last one. Again, same idea, we're going to distribute. So 3 times 4 is 12x. 3 times negative 2 is negative 6y. Now here's where you need to be careful. Okay? Over here it didn't matter, it was a plus. If it's a negative, I need to group that together and take that negative with it. So negative 2 times 3 is negative 6x, and negative 2 times 1 is negative 2y. Okay? A lot of times you'll get this first one, but you'll forget to take the negative with the second one. Okay, so now I can combine like terms. Again, x's combined, 12x minus 6x, and that leaves me with 6x. Negative 6y minus 2y, negative 8y, and we're done.